Hello everyone, I'm going to show you exercise 36, which is quite different than the other ones because they don't ask you here to calculate the value of an angle. They ask you to calculate whether D is the midpoint of line AE. And to understand what that actually means is quite important. If you want to understand what this means, that means that if this is the midpoint, they mean that I have to find out whether the length of AD, I'm going to notate it like this, is AD equal to DE or not? Okay, that's the question. How can I answer that question? Well, there are multiple ways, I think, but they don't give you any lengths, so I cannot work with lengths of sides because, yeah, I only have the measurements of angles right here. What I want you to do is calculate whether angles are the same, right? Because if I know if certain angles are the same, well, then I can also say whether certain lines are equally long. And in this case, I do know that angle A2 is equal to angle C1. That's given, right? That means that triangle ADC is an isosceles triangle. Because those two lines in this, I must say it correctly, those two lines are the same. These are the legs, this is the base, D1 is the vertex angle. That means that AD is actually the same as DC, right? So I do know that AD is the same as CD because of an isosceles triangle. Hey, but I'm trying to find out whether AD is equal to DE. But that means that that's actually the same as finding out whether DE is equal to CD. Right? And if CE is also equal to DE, that means that this is a equilateral triangle. And if AD is the same as CD is the same as ED, that means that this must be the midpoint of line AE. How can I try to find that? Well, if I can just show you guys that CDE is an equilateral triangle, then I'm done. How can I show that? Well, let's take a look. Can I calculate angle E1? I think I can, because angle E2 is 180 minus 15 minus 45 equals 120. Angle sum, triangle. And that means angle E1 must be 180 minus 120 equals 60 degrees because of the straight angle. Hey, that's nice. I already know this one is 60 degrees. Now, can I also calculate any other angles here? Well, I do know that angle C12 is 90 degrees. So angle A12 is going to be 180 minus 45 minus 90 equals 45 degrees. So how much? This is again angle sum. Angle sum. T triangle. I'm going to abbreviate it. angle A2 in that case must be, let's say it correctly, 45 minus 15, because A1 is 15, equals 30 degrees. Hey, but if angle A2 is 30 degrees, then angle A1 is also 30 degrees, right? Because they are the same, because of the isosceles triangle. Isosceles triangle. And that means I can now calculate angle D1. Or I could even do it easier. I think it's maybe even easier to now calculate C2. There are multiple ways here again. I say angle C2 is going to be 90 minus 30 equals 60 degrees. And all has to do with a right angle. Right, because if I'm going to show you right now, this is 90 degrees. A1 is 30, so C2 must be 90 minus 30 is 60 degrees. So I now know C2 is 60, E1 is 60. Yeah, now I can calculate D2. I have to create a bit more space for myself. That means angle D2. I now use the angle sum methods. 60 minus 60 is 60 degrees. Because of the angle sum of the triangle. Let's abbreviate that. Okay. But because all the angles are 60 degrees, right? I've just shown you that angle D2 is 60, E1 is 60, C2 is 60. So triangle DEC, oh, it's acting out again. Why is it always acting out in the end? Why? It feels that I'm almost done, I think. Triangle D. Yeah, I'm not going to do it like this. Let's start typing again. So, triangle DC. Did I say it correctly? DCE? DEC? Let's do it like this. Is equals, come up, equals, or is, I could rather say, is an equilateral triangle because all angles are 60 degrees. That means in this case that DE is equal to CD, and we know that CD is equal to AD. So that's going to be my next step. Ching, 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 ching. Let's get rid of this. Oh, sometimes this program is such a nightmare. Okay, let's do it like this. So AC equals, let's use capital letters, AC equals DC equals, not even AC, AD, CD, AD, CD, and last but not least, DE. DE are the same lengths. So you could say that point D is the midpoint. Why can I now say that? Well, because AD is equal in length in DE, and that's why point D should be a midpoint or not. Okay. Again, my apologies for this terrible ending here. I can just erase those. I can maybe zoom out a bit. Is that possible right here? Again, I'm searching for a way to zoom out so I could show you the exercise in one go. No, I cannot do it. Okay, so to recap, I want to find out whether AD equals DE, and to do that I can use the knowledge that ED is actually the same as CD. So if I can now find out that ED is equal to CD to equal to ED, then this must be the midpoint. And I try to find that by trying to search whether this is an equilateral triangle or not. And when I find out all those angles are 60 degrees, I can say this must be an equilateral triangle. So ED must equal CD. And because of this isosceles triangle right here, I know that CD equals AD, so AD must also equal DE. Okay, this is a very difficult one. It's another plus exercise with this symbol here for nothing. This is a very difficult one. So if you find this a bit too difficult, don't worry too much. Okay, I will leave it like this if you want to read everything and the last thing. And good luck to you all again.